Hey everybody, this is Alex Merced from alexmerced.com, and it's been a while since I've done a video on my two YouTube channels. But I figured I would do one because this is a really exciting topic. This is the topic of MCP, Model Context Protocol. And the idea behind Model Context Protocol is right now one of the big things is creating agentic AI applications. What does that mean? Usually when you work with something like a ChatGPT or a Claude slash Anthropic or a Gemini, generally everything's very text-based, right? Like I can go to, let's say here, if I go to gemini.google.com, okay, and I get like a nice fresh prompt here. Okay, and I say, hey, list me 20 types of cheeses from Wisconsin. Okay, basically what it's going to do is going to generate me a response that's text. Okay, bottom line, I provide it text. It then basically is going to go do all that vector search stuff where it's basically going to turn my prompt into a vector and then find sort of the most similar vectors in there and then give me back sort of that result. Okay, and then again, all those vectors are generated during the training, all that fun stuff. Great, I got a list of cheeses. But the problem is that this is text in and text out. What if I wanted to do things for me? Like I can have it generate me an email. Okay, so for example, I want to write an email to my email list about these cheeses. Can you generate the email? Okay, and then it'll generate a email. Okay, so there it is. Okay, wonderful. Okay, and that's very convenient. But the thing is that I would then have to copy and paste this over into Gmail or to MailChimp or whatever my preferred email tool is. And basically, there's extra steps that I still have to manually do. And again, the end goal and with a lot of this AI stuff is to try to reduce as much sort of the manual work as possible. So this is where agentic AI comes in. This is the idea here is to create applications that interact with the LLM, the chat AI. And basically what it does is that the AI agent is aware of several things it can do, several actions it can take. These are generally in the form of tools, which are just functions. And the idea is that it will provide, when it prompts the LLM with your question, it's also going to say, hey, LLM, here's the question that I have, but just so you know, I'm also able to use these tools, and here's what they do. Tell me if you think we need to use them to do what we were asked to do. Okay, and then the LLM will respond with do X, Y, and Z. Okay, and then the program, the agent, can then invoke those functions to do those things. Okay, problem is you would use frameworks like LangChain, which we're going to use in this video, but you would have to kind of create those tools for every bespoke agent. Okay, so you find yourself re-implementing the same logic over and over and over again to do the same things, because every agent had to be built sort of custom made. So the beauty of MCP, Model Context Protocol, is the idea is that you can create these server applications that can become sort of the bundler of, you know, common tools, basically actions you can take, resources, sort of context and data you can request, and prompts, sample prompts for accomplishing certain tasks to better understand sort of what the steps are for a certain task and bundle them into a server. So instead of me having to building all the functionality into every individual agent, I can build an agent with LangChain that connects to different MCP servers, and then it inherits those unique levels of functionality from those different MCP servers. So I could inherit from like let's say a SendGrid MCP server that'll let me send emails, okay, or a Twilio MCP server that'll let me send texts, and a Dremio MCP server that'll let me go pull my client information from my data sources. Okay, each MCP servers will grant an expanded set of sort of functionality to what the agent can do, and now I can put in prompts and say, hey, you know what? Go fetch the customer data, then create an email template, then go use SendGrid to send that email to these particular clients. And using the tools that it would have from the different MCP servers that are connected to it, it can actually go do that for me without me having to do anything else other than ask. Okay, that's sort of the beauty of agentic AI, the ability to be able to prompt and have things actually done for me, and then MCP being able to modularize that those tools. So now we know what MCP is. Okay, but what I've done is right now, generally the main MCP client is Claude Desktop. So the easiest way to use MCP is use Claude Desktop. What I've done is since I use Linux, I can't use Claude Desktop on Linux. I've created my own MCP client that you can use with any MCP server right here. Okay, and then you can make your own copy of it if you want to edit it by clicking use this template, so that we can build your own, because it also has the functionality for you to build your MCP servers within the client if you want. But basically, here's the repo. I'll put the link in the video description. But yeah, first step is we're just gonna clone the repo. So I'm gonna go clone the repo. Okay. So let me go open up a terminal in my VS Code. I'm opened up to like an empty folder to work out of. Terminal, new terminal. Close this window. Okay, so let's do git clone the URL to the repo. Okay, and then we can see that it got cloned right over here. Wonderful. Okay, now the thing is I'm going to need sort of a I'm going to need a virtual environment in Python in order to install my dependencies. So what I'm going to do is I am just going to create that virtual environment right here. Oh, not right there. I'm going to use the CLI to do that. So I'm going to use this traditional Python environment. So Python -m -v. That creates the Python virtual environment. Okay. Cool. And then what I'm going to do is I'm going to activate that environment. Python source -v/bin/activate. And again, if you don't know what I'm doing right now with this virtual environment, if you refer to my older Python videos, or I have several Python blogs, just go to alexmerced.com to find my blogs, where I go into detail about what Python virtual environments are and how to set them up and your different options. And those options have only grown because now there's things like UV, which I haven't written blogs on before. But yeah, so there I've activated, and I can tell that it's activated because I can see this little VENV right here. Okay, so what does that mean? It just means that now I'm going to be operating from an isolated sort of Python environment where right now it has like no dependencies. So if I go inside my LangChain MCP client, I know there's a requirements.txt. That's sort of the listing of all the dependencies I need. Okay, let me just make sure everything's in there. Do I see F? Make sure Flask is in there. Fast MCP, yes. I have a feeling that I put Flask in here, didn't I? Yep, there's Flask. Okay. Yep. So what I'm going to do, I have to go fix the original repo, which I'll do right after this video. But really, this is the right list. So I'm going to copy this over here. There we go. Okay. So then what I'm going to do is I'm going to basically cd into this folder, LangChain MCP Client, and I'm going to install those requirements by doing pip -r. So it's going to recursively just install the list of requirements. Pip install -r requirements.txt. Okay, and now it's going to work its way through all those different dependencies. Install them. This will take a moment. Okay. And then once that's done, basically now things should be working. Now the other piece that's going to be missing is that I'm going to need to take this example.env and I'm going to rename this to .env. Okay, so here's where all my sensitive variables are going to be, and what I need to put here is what LLM model I'm going to put in there. I'm going to be using GPT-4.1, and then I need to put in my API key for that particular model. So again, depending on which model you're using, you just put in your right API key for the right variable. Okay. And then detailed output, don't worry about that. You can just leave it as false unless for some reason you really want more verbose output from your LLM, where it shows you the entire context object from LangChain. Yeah, so what I'm going to do is I'm going to put in my API key here. So I'm not going to open this file again, but just know you need to make sure that this is filled out. Okay. Okay, cool. So I'm going to pause the video and do that. Okay, so now that I have my API key in the .env and I have my dependencies installed, technically I already have two example MCP servers here in this folder, this math server.py and this weather server.py, just to show you sort of what an MCP server looks like. Okay, using this fast MCP framework, all we're doing is we're creating an MCP server and we give it a name. And the names are very important here because the names are where all this text is what's going to be delivered to the LLM, because again, it's not going to read your code. It's going to get delivered all this text that gives it context. Okay. So in this case right here, we see here, we're defining a function. Okay. And this is going to be a tool, an MCP tool. And the comment is being used as a descriptor. Okay. So that comment is going to be provided as a way for in this case, OpenAI to know that, hey, this tool is for adding two numbers. This tool is for multiplying two numbers. Okay, and then right here, so again, we define each tool. We put the tool decorator on there. We define it. We make sure we put some comments in there. Okay, it's just, again, a function that is going to define what it does. Okay, and then here we're going to then run it. And notice that it says transport. Now, this transport piece is pretty important because it determines how does the MCP, how does your agent going to communicate with the MCP server? In this case, is using standard input outputs. Essentially, what it's going to do, it's going to kickstart a process of that server, and then basically communicate through its standard input and output. Okay, so it'll send messages back through standard input, and then get messages back through standard input, not through like TCP/IP, not through HTTP calls. But the weather server here, now notice, in this case, it is HTTP. So in this case, it is going to be a server running on a TCP/IP port 8000, okay, and it's going to have a particular path /MCP in which you use to communicate with it, okay. Cool. So you can kind of see the difference between the two. And then again, otherwise, it's the same thing where we create functions, we wrap them in the decorator for the MCP, so that way it knows it's a tool. The comment gets used as a descriptor for that tool, and then we have the actual function that does a thing. So basically, the LLM is going to get these descriptions, these comments, and it's going to know which ones it wants to use based on those comments. Okay. Now, in this case, theoretically, the math server should be spun up when I spin up the MCP server. And again, how does my client know which MCP servers to use? There's this MCP servers.json file here. So in this case, here's where you would configure which MCP servers this client will connect to when you start it up. Okay, so for example, in this case, I have the math server, which again, what I do is I tell it, hey, basically I have to give it the command to start the server. Okay, and then I tell it what transport. Now, when it's an HTTP server, since it doesn't have to initiate the process, I just have to tell it, hey, where are you making MCP? Where are you making these API calls to? What's the URL? And again, what's the transport? So it knows that, hey, I'm making HTTP calls, not starting a process and communicating with its input output. Okay, cool. So to keep it simple, I'm going to cut the weather out one for now. So I'm going to just cut that out. Okay, take out actually cut out that comma too. Okay, so now now I can just run the client. So I can just do python client.py, and this should start the client. And let's see what happens. Okay, good. It's starting. And yeah, look, see, and it connected to the MCP servers. Wonderful. That's exactly what we should expect to see. Okay, in this case, again, I didn't have to initially start the math server because when you're using that standard input-output type transport, the MCP server will go kickstart that process as a child process and communicate with that child process. So now I can just sit there and say, hey, add the numbers 5 and 7. Okay, and then there it goes. So you see it says it's going to start using the math server MCP server. Okay, and then it gets back the response that the agent, the sum of 5 and 7 is 12, and there I go, I got my response. Okay, now could a normal prompt handle that? Yes, but the idea is that that function built in that math server could do anything. Again, it could be sending emails on SendGrid, text through Twilio, querying Dremio, whatever you needed to do, these functions can do. Okay, now what I'm going to do is you just type an exit to leave this interface. Okay, now what if I do want to use the math server, okay, or the weather server, okay? Again, this time it's going to try to communicate with a running server. So in this case, I do need to make sure I run that server. So I'm going to actually probably do that as a separate terminal altogether. So let me just add another terminal here. Okay, I need to kickstart the virtual environment. So source dot slash venv slash bin slash activate. Good. Okay. And then what I can do is I'm going to cd into langchain slash MCP servers. And then I'm going to just run that math server. Run Python math server, no, not math server, weather server.py. Okay, now I have that server running on port 8000 in that terminal. Go back to my original terminal and I'll start the client again. Okay, and wonderful. Now I can sit there and say, hey, you know what? What is the weather today here in Orlando, Florida? Okay, and then again, it's going to use that server. So it says, what is the weather today? Okay, the weather today in Orlando, Florida is sunny. If you need more specific details, yeah, send me the temperature. Give me the temperature right now in Orlando. See what it says. Okay, it's doing its thing. It's currently sunny in Orlando. If you need the exact temperature, please let me know. I did ask for the. Let me see here. Let's take a look at that weather server. Okay, so in this case, it's just hard coded in there, but so in this case, the response is hard coded. But again, the idea is I could go hit a weather API, pull that data, whatnot. So I could sit there and say, hey, Orlando, and then maybe have a tool in there that goes and gets the zip code and then uses the zip code and goes to a weather, and then another tool that actually takes that zip code and hits the weather API. Again, you have to think through, the way you want to think through it is what would be the steps that I would need to do to complete the typical requests that I'm going to ask this server to do, and then create a tool for each of those steps. So in that case, if I'm thinking weather, I'm probably going to need a zip code, because most APIs oftentimes are going to use a zip code or some sort of a latitude, longitude, or something to kind of identify where the weather's for. So then based on your prompt, I need to kind of be able to gather what that latitude, longitude is, or what that API is, create a function that does that, then create another tool that then goes and hits the weather API for the weather, and so forth and so forth. So the idea is that, again, whatever you can imagine, whatever you can think through stepwise, you can create the tools, because the idea is that you're not going to do all the steps yourself. You're providing all the tools and enough context so that way the LLM can think through the steps that you've pre-made for it, but being able to do it for someone who doesn't know how to program can just type in a prompt, and then the LLM can handle filling in the gaps and coming up with those steps and on its own. Okay, so that's the CLI interface. But also into this repo, I created a web UI interface, so that way you can get a visual interface. So for that, you're going to run this web UI.py file. So now if I run in python.webui.py, okay, I now have it running on port 5000. So now I can just go back to my browser, go to localhost 5000. Okay, and here I have this MCP client where I can ask it the same question. So like, hey, what is the sum of 10 and 5? Okay, and again, just gotta wait for the response. The sum of 10 and 5 is 15. Okay. What is the weather in Orlando? Okay, and so you can see it is using, like, again, that is the right hard-coded response from that tool. And this all looks like the way that those tools should be responding based on the way those tools were designed. Okay, but again, basically in this repo, you get a nice visual UI if you want to use a visual UI. And again, I can reset this by just clicking this little reset chat history button here. And then, or I can use a CLI interface. Either way works. But yeah, that's here. So this is a great way to kind of get started with MCP. Again, because you already have all the dependencies kind of installed, you can begin actually creating your own MCP servers in this folder. If you want, and then again just configure them in MCP servers here. And again, if you have other MCP servers you're connecting with externally, you can just do them sort of out here. Let's just set them up in here, and then this client will be able to use it. So hopefully you guys enjoyed this, and this gives you a nice sort of kickstart in sort of using Python to write MCP servers, and a tool for you to test out those MCP servers and develop those MCP servers. And otherwise, have a great day and enjoy.